Okay, so our first few here, we're going to cover pretty quickly. Most of the mistakes made on the first 3 or 4 problems are just kind of going too fast. Let's take a look here. This is test 3. So problem number 1. We're asking for a 3 in 18 dilution. What is the ratio of ammonia to water? Now remember, in a 3 in 18 dilution, that's 3 to 18, or if we reduce that 1 to 6, that's serum to total. So that'd be ammonia to total. Ammonia to water would be 1 to 5. If 1 out of the 6 parts is ammonia, the other 5 parts has to be water. Number 2, in a 22% volume in volume solution, blank milliliters of concentrate is into 100 cc's of solution. Well, remember, in a volume in volume, it is concentrate to total. That equals your percent over 100. Have to be the same units. However, a milliliter and a cc are the same thing. So that is 100 milliliters. So that is blank amount of concentrate over the 100 milliliters total equals 22 over 100 is our percent. If you cross multiply and divide, that ends up being 22 milliliters of concentrate. Number 3. I didn't notice it till after we got going on the test. There's a slight misprint there. It should have been a 12%. Instead of volume and weight, it should have been a weight in volume solution. Has blank grams per 100 milliliters. Well, again, a weight in volume is your weight in grams over your volume in milliliters equals your percent over 100. So it's the same thing here. You're going to put 100 milliliters in for your volume, and 12% cross multiply and divide comes out to be 12 grams. So I was trying to be nice on those two. Number 4. Common mistake here is just answering the wrong question. We have a 1 in 8 dilution of serum and saline. If the total volume is 160, well, remember, in a 1 in 8 dilution, this is serum to total volume, so the 8 is total. So 160 can go with that. What is the volume of saline? Well, we're looking for saline, not serum. So the ratio of 1 to 8, so we don't need the 1 to 8 ratio of serum to total. What we need is the saline to total. Again, 1 out of 8 parts is serum, so 7 out of 8 parts is saline. Cross multiply and divide. 7 times 160 divided by 8 is 140 microliters of saline needed. 50 milligrams of liquid is ordered, so you get 50 milligrams is our order. The on-hand dose is, that's our label on the bottle, is 30 milligrams in 2 milliliters. How many milliliters would you give? So 50 milligrams, we'll put it over 1 to make it a fraction. Milligrams will go on bottom so that they cross cancel out. And it is 30 milligrams in 2 milliliters. Milligrams cancel. The 1s cancel. We got 5 times 2 is 10 milliliters over 3, so 3.33 milliliters, or 3 1/3 milliliters. 6, a little bit tougher. We have cefazoline is to be given in a dosage of 30 milligrams per kilogram per day. Child weighs 42 pounds. How much would be given each day? So first thing, we're going to take the 42 pounds and we're going to convert it by dividing by 2.2 to convert to kilograms. Oops, what's going on here? figure things out. 42 divided by 2.2. 19.09 pounds, or kilograms. Could have rounded to 19.1, or even sometimes they round it straight to 19. We're going to leave it as 19.09 to stay as exact as we can for now. And we know it is 30 milligrams per 1 kilogram, and that's per day, equals blank milligrams per 19.09 kilograms. Cross multiply and divide. 30 times 19.09 is going to be 572.7 milligrams. Any questions on the first page that you want me to go back over? I realize you guys don't have your tests back yet, so it's not quite as meaningful to you. You don't know exactly which ones you got wrong, but hopefully you'll see which ones you've got wrong and be able to write them down. I did receive most of the tests this morning. I think there's one batch that I'm waiting for yet. So number 7, IV flow rate for 80 milliliters infused over 30 minutes. This is one where you actually have to look at the answer and see what units it's asking for. You can see in the answer it's looking for milliliters per hour. So we have to convert this to hours. So minutes are going to go on top. Hours on bottom. 1 hour is 60 minutes. The minutes cancel out. I'm going to cross cancel the 30 and 60 to give me 1 and 2. So 80 milliliters times 2 is 160 milliliters. 1 times 1 hour is 1 hour. So 160 milliliters per hour. Problem number 8. Find the IV flow rate for 300 milliliters infused over 4 hours. So here it's 300 milliliters over 4 hours. And once again, we're looking at milliliters per hour. We are just dividing this out. 300 divided by 4 is 75 milliliters per hour. Number 9. An order calls for 500 milliliters to be infused over 4 hours. Drop factor is 10 drops per milliliter. Find the flow rate. And again, here's when you got to look at the solutions asked for drops per minute. So we're going to have to convert this to drops per minute. First thing I would do is I would divide this out. 500 divided by 4 is going to be 125 milliliters per 1 hour. Next, I'm going to convert that into minutes. Hours on top, minutes on bottom. 1 hour is 60 minutes. That's going to give me milliliters per minute once the hours cancel out. And I want drops per minute. So I'm going to go my next step right here as well. I'm going to put drops per milliliter to cancel out the milliliters. So 10 drops in 1 milliliter. So here I have 125 times 1 times 10 drops is 1,250 drops over 1 times 60 minutes times 1 is 60 minutes. And if I divide that out, 1,250 divided by 60 gives me 20.8333 drops per minute. And we had mentioned whenever we're dealing with drops per minute, we usually round it to the nearest drop. If you had 20.83, I would accept it, or 21 drops per minute. 10, similar problem. 1 liter to be infused over 5 hours. Drop factor of 20 drops per milliliter. First thing I'm going to do is I'm just going to change this 1 liter I know is 1,000 milliliters over 5 hours. Now I'm going to divide that out. 1,000 divided by 5 is 200 milliliters per 1 hour. Or, sorry, not 200. 2,200. Get rid of the 0. There we go. 200 milliliters per hour. So now I can start from there. 200 milliliters per 1 hour. I'm going to get rid of the hours and convert to minutes. 1 hour is 60 minutes, so my hours have now cross-canceled out. And I get rid of my milliliters and go to drops. 20 drops per 1 milliliter. My milliliters will cancel out. So I have 200 times 1 times 20 drops is 4,000 drops. 1 times 60 minutes times 1 is 60 minutes. I divide that out, and I am going to get 66.666 drops per minute, or rounded to 67 drops per minute. Again, if you had the 66.67 or whatever, that would have been acceptable. Any questions on those few on IV flow rate so far? Okay, number 11. On this one, we're given that the flow rate is set at 30 drops per minute with a drop factor of 10 drops per milliliter. We want to know how long is it going to take to infuse 900 milliliters of liquid medication, of fluid. And we're asked for our answer to be given in hours. So here we start out with our drop factor. We're working backwards. 10 drops per 1 milliliter. Or sorry, drop factor. We don't start with our drop factor. We start with our flow rate, 30 drops per minute. So that's 30 drops per 1 minute. And now we use that, using our drop factor, to convert that. Now drops have to go on bottom so they cross cancel out. So milliliters will go on top here now. So this will give us now milliliters per minute. 30 times 1 is 30 milliliters. 1 times 10 is 10 minutes. So 30 milliliters in 10 minutes, are dividing that out. That is 3 milliliters per 1 minute. And now we need to figure out how long it's going to take for 900 milliliters. Well, we have 3 milliliters in 1 minute. How long is it going to take for 900 milliliters? This is a proportion now because we're keeping the same units. We're still keeping milliliters and minutes. We're just changing the numbers from 3 milliliters to 900 milliliters. So we cross multiply and divide here, and we find that 3 milliliters in 1 minute means 900 milliliters will take 300 minutes. And from there, since we want the answer in hours, it's simply a matter of taking 30 minutes, or 300 minutes, and converting it into hours to get 5 hours. So it takes 5 hours to infuse 900 milliliters at that flow rate of 30 drops per minute. Number 12, last one on the second page. Physician orders a dosage of 60 milligrams per kilogram for every 8 hours for a patient who weighs 190 pounds. So first step, we're going to divide this by 2.2 to get $86.36 kilograms. How many milligrams should be administered every 8 hours, and how much should a patient receive during the course of an entire day? So we're going to stick with just looking at every 8 hours for right now. So the 60 milligrams per 1 kilogram. How much is it going to be for 86.36 kilograms? You're going to cross multiply and divide here. Oops, here's that. 60 times 86.36 divided by 1. So just be 60 times 86.36. Goes 5,181.6 milligrams. That is the per 8 hours. For a day, we just multiply that by 3. So 15,544.8 milligrams per day. Now, if you had rounded off the weight, the kilograms a little differently, of 86.4, it would be slightly different. And my answer key does account for that. Anywhere from basically 5180 to 5182 here, and then whatever the corresponding result would be for the day. Any questions on page 2 before we move on? Cool. Well, we're over halfway there. Page 13, physician orders a single dose of 50 milligrams of methotrexate for a child who weighs 40 kilograms and is 125 centimeters tall. Recommended pediatric dose is 25 to 75 milligrams per meter squared per week. The strength on the bottle is 25 milligrams per milliliter. Is this a safe dose? Well, first thing, it looks to me like this is useless information. Since the doctor's dose was given in milligrams instead of milliliters, we don't need that for anything. So next, first we got to find out the body surface area, which is going to be the square root of the height times the weight. Since that's in metric, it'll be over 3,600. So second square root, 125 times 40 divided by 3,600. 1.18 square meters. Now, since we're going to get safe dose, I'm going to look at the upper end first, 75 milligrams per 1 meter squared. It's going to be how much per 1.18 meters squared? Cross multiply and divide. 75 times 1.18 divided by 1. $88.5 milligrams. 50 milligrams is definitely below that. Let's make sure that it's not below the minimum. So we'll do a quick titration here. 88.5 milligrams. We used 75 milligrams. We want to convert that to what it would be for 25 milligrams. That'd be 29.5 milligrams per day or per week. So that 50 milligrams is definitely within that range of 29 to 88.5. So this is a safe dose. 14. A patient is to receive 3 milligrams per meter squared of Oncovin. Supply dosage is 10 milligrams per 1 milliliter. How many milligrams does the patient receive and how many milliliters should be given? So this is 3 milligrams per 1 meter squared for a patient that is 0.65 meters squared of body surface area. So you're going to cross multiply and divide. So we cross multiply and divide, we should get 1.95 milligrams. Convert that to milliliters. That's 1.95 milligrams. Put it over 1. It's 10 milligrams per 1 milliliter. So the milligrams cancel out. That is 1.95 over 10, or 0.195 milliliters. Number 15. Patient is ordered amoxil, 0.250 grams, POQ8H, in other words, by mouth every 8 hours. Available supply is 100 milligrams per 5 milliliters. The first thing I'm going to do is I'm going to convert 0.25 grams into 250 milligrams. Just moving the decimal point from grams to milligrams. Next, I take that 250 milligrams, put it over 1, and we're going to convert. Milligrams will go on bottom, milliliters on top. And it tells us 100 milligrams per 5 milliliters. Milligrams cancel. That is 1,250 milliliters over 100. Divides out to be 12.5 milliliters. 16. We need to make 400 milliliters of 3% KCl, so potassium chloride solution, by diluting 8% solution. How much is needed? So we're just using the concentration adjustment formula, volume times concentration. So 400 times 3 equals volume times concentration. So V2 times 8. 400 times 3 is 1,200 equals V times 8. We divide by 8. This is 1,200. 1,200 divided by 8 is 150. Is our volume. The other volume is in milliliters, so this is in milliliters. So 150 milliliters. 17. Same thing. We're using the concentration adjustment formula. We have 80 milliliters of 3.5%. If water is added to make 190 milliliters, find the new percent, new concentration. So 80 times 3.5 is 280 equals 190 times C. We shall divide by 190, which will give us 1.47 equals C. So our new concentration is 1.47%. 8. An order is given for Enduron 2.5 milligrams by mouth QD 4 times daily. You have Enduron 0.5 milligram groove tablets. How many tablets will you give? Number 18, you have an order 2.5 milligrams. Milligrams on bottom, we have 0.5 milligram tablet, so 0.5 milligrams per 1 tablet. Milligrams cancel, it's 2.5 tablets over 0.5. You divide that out, that's 5 tablets. Any questions on page 3? So here we go on page 4, last page. Number 19. Doctor calls for phenobarbital, 0.05 grams. 0.05 grams by mouth. Phenobarbital elixir, GRSS per milliliter is available. So GRSS per milliliter. How many milliliters do we give? Well, first thing here, GRSS stands for 1/2 grain per 1 milliliter is what that says. So the first thing I would have to do is convert 0.05 grams into grains. Now, if we look up on our conversions, we know that there are how many grains in a gram? Grams go on bottom, grains on top. We know that 1 gram is 15 grains, if I'm remembering correctly. That's one I always stumble on a bit. So the grams cross cancel. 0.05 times 15 is 0.75. There we go. So now we're going to take our 0.75 grains over 1, and we'll convert. 1/2, I'm going to write as 0.5. 1 milliliter. Grains cancel out. I get 0.75 over 0.5. That's milliliters on top now. Which divides out to be 1.5 milliliters. Number 20. Order calls for Motrin, 600 milligrams. Supply is in GRV tablets. GRV means 5 grain tablets. So we're going to have to convert milligrams into grains. You know that 1 milligram, or sorry, not 1 milligram. 1 grain is 60 milligrams. So that's 600 grains over 60, or 10 grains. So we're ordered to give 10 grains, and we have 5 grain tablets. So grains cancel out. We have 10 tablets over 5, or 2 tablets. This one, again, both 19 and 20 can be altered just slightly depending on whether you go from milligrams to grains or if you go from grams to grains. Because remember, that conversion is slightly off. So there's a little bit of a slop if you're off just a touch. Like for number 19, if you converted your 0.05 grams into 50 milligrams, then it actually comes up to like 1.6 instead of 1.5 because of the slop in those conversions there. Any questions on those two, 19 and 20? Okay, let's hit 21. 21 had quite a bit of extra information. All we really care about there is the orders for Gaviscon, 80 milliliters. We don't care how big the bottle is. The bottle happens to come in a 7-ounce bottle. We want to know how many ounces. Our conversion between milliliters and ounces. I'll just put down as ounces. Is 1 ounce is 30 milliliters. You could also use 29.9 milliliters, depending on where you look in the book. That conversion is given differently. This is 80 ounces over 30, otherwise known as 2.67, or 2 2/3 ounces. 22. Final concentration of saline solution, 40%. Sodium chloride is diluted using a 1/8 dilution. Remember, we just take the percent times the dilution. So 40 times 1/8 is 5% is our new concentration. 23. Physician orders 80 milligrams intermuscular injectable solution. Only a vial solution has a strength of 100 milligrams per 2 milliliters on hand. So we have an order for 80 milligrams. Put it over 1. We're going to convert milligrams into milliliters. We have 100 milligrams per 2 milliliters. Milligrams cross cancel. 80 times 2 milliliters is 160 milliliters over 100 milligrams. Divide that out, we get 1.6. So 100 milliliters over 100. 1.6 milliliters is our answer. And finally, number 24. I know, I sound way too excited about that. Mr. Jones receives 100 milligrams by mouth. Inderol. You have Inderol 30 milligram scored tablets. So we're going to make this over 1. 30 milligrams will go on bottom per tablet. So the milligrams cross cancel. You have 100 tablets over 30, which is 3.33 tablets. Now that is not our answer quite yet because they're scored tablets. That means we have to round to the nearest half tablet. And it actually tells you in the instructions round to the nearest half tablet. 3.33 is between 3 tablets and 3.5 or 3.5 tablets. So 3.33 is here closer to 3.5. So the answer there is 3.5 or 3.5 tablets. Any questions? Okay, well, wonderful. That is it for today. No homework. So we've had a couple of easy days here with the tests and this. Wednesday, next class, we will start our graphing unit. That'll take us approximately 4 or 5 class periods to get through the unit. Then we'll do our test. And then we'll wrap up with the semester with some basic statistics for the last couple of weeks. You guys have a great day, and we'll see you on Wednesday.